This recording is going to look at the Alcom question focusing on CVP analysis. So this is just a revision of the question we went through in class, just to make sure we can consolidate our knowledge and we're covering the key topics. So in this question, you're given the total information, the total profit statement, and you're told they made 15,000 units. And your first question is selling price and variable cost of 1 unit. Now the key point here for part 1 was that we have to assume a constant price per unit and a constant variable cost per unit. So to get that, so we just bring in this for example. If we have our sales revenue of 450, well, we'll say that represents sales of 15,000. So the average selling price per unit, which is what part 1 is asking us, is €30 a unit. So €30 flat. So that's the sales price per unit. Alright, so there's a number of ways you can go about it, but just make sure you understand exactly what's been asked. You're asked the selling price per unit. If you have the total units and you have the total money, you divide one into the other. Exact same with variable cost. You have 180,000 full variable cost. Variable cost means it's going to be a price per unit. Every extra unit you have an extra variable cost. So it's 180 divided by another 15,000, meaning here the variable cost is €12 a unit. Variable cost per unit. So essentially what you're saying is it's costing you €12 to make it and you're selling it for 30. So every extra unit you make is making you €18. So €18, what we call contribution per unit. So your contribution is your sales minus your variable costs. So that's a key concept in CVP analysis. So for every extra unit you sell, you're making €18 to contribute, it's where the word comes from, to contribute towards fixed costs. So that is your part 1 answered. In part 2 then they ask, what is the break even? So what's the break even point? Now the break even point, remember, is when you make neither a profit nor a loss. So what you're trying to say is, well, what is the amount of units we have to sell just to break even? Now how we calculate the break even, so if you want to do the break even point in units, that is equal to your fixed costs divided by your contribution per unit. All right, so that's an important one. Let's see if we bring this up a bit bigger. So your fixed cost divided by your CPU. So if we want to get the break-even point, how many units do we need to sell just to break even? We know what our fixed costs are. They're 216,000. These aren't tracked by a unit. No matter what the number of units are, your fixed costs are going to stay the same. So that's an assumption around CVP as well. So in this case, it's going to be 216,000 divided by your contribution per unit we've just calculated is 18. So essentially what we're asking is, how many units at €18 do we have to sell to get 216,000? And your break-even point there will be 12,000 units. So we need to sell 12,000 units just to break even. Now you're asked it in both terms, so in units and in sales revenue. So if we sold 12,000 units, it's 12 at 30. So that's the €30 per unit that you sell at. So there's two ways of representing it. Either we need to sell 12,000 units or we need to make 360 worth of euro sales. Either one of those answers, both are required in this instance. And again, we can just prove that. Well, are we sure that that's correct? If we do sell 12,000 units, what will our profit be? So you have sales, less your variable costs, less your fixed costs. So we'll just do a little profit statement to see. Well, if we sell 12,000 units, we'll have 360,000 of sales. We've just calculated that. If we sell 12,000 units, you're going to have variable costs, 12,000 times, just double check up here, 12, which is 144,000. So that means, so that's a minus figure, so that means your contribution then is 216. Your Your contribution is 216, which is 360, and that's a minus. I'll just make that a bit clearer. Just bear with me. Let's make that a small bit clearer. And then your fixed costs are also 216. So therefore your profit at that level is nil. So it's no harm, particularly at the start, just to make sure you can prove that that's the break-even point. If I sell 12,000, I have that much contribution and it just covers fixed costs. So that actually answers our part 3 as well. What is the total contribution at the break-even point? The total contribution at the break-even point, where you neither make a profit nor a loss, will always be the amount of fixed costs. So the answer to part 3 there is contribution must be 216,000, because that will just cover your fixed costs. So that's your answer to part 3 as well. Part 4 then we get into more specific items around particular questions we want to ask. In this case you're asked how many units needs to be sold to generate a profit of 90,000. Now there's two ways of going about this. The traditional way we just look at is the units required. It's very similar to our break-even formula. You then do target profit plus your fixed costs, and you divide by your CPU. So the only difference here is before we just divided by had fixed costs in the top because we just needed to cover that. Now we need to cover fixed costs and your target profit. So we're just adding on an extra hurdle. So in this case it's going to look like 90 plus 216 divided by 18. So the 18 hasn't changed. That's still your contribution per unit. So what we want to know now from part 4 is how many units do we sell at €18 contribution to cover, not only cover the 216, but also generate a profit of 90. So in that case, we need to cover 306,000, which is those two added together, divided by 18. Or you need to sell 17,000 units. So if we sell 17,000 units, we should make a profit of 90. And again, no harm, see can you check that. So see can you prove it. So use this layout here. Can you prove at 17,000 units what your profit should be? So just pause it now and see can you prove yourself. Do you get down to your 90? So it's 17,000 units, you sell out at 30. So that'll be 510,000. You'll have 17,000 units. You pay variable costs, so each cost, your buying costs, your commission costs, etc. come to 12, which is minus 204. Sales minus variable costs gets you your contribution. That's 306. And then we take off our 216, which is our fixed cost. Remember, no matter where your volume changes, your fixed costs stay the same. That's the concept of fixed costs. And thankfully, when we take one from the other, our profit is our target profit of 90. So we know we're correct. Part 4 answer, you need to sell 17,000 units to generate a profit of 90. Now there's other ways of going about that. As long as you get to the 90 and you get to the 17,000 units, you'll get your full credit. Part 5 asks us a slightly trickier one. They're asking us, if we increase our sales by 50,000 this quarter, what will the impact on profit be? So there's two ways of going about this. The first way, we'll say one, is using your contribution margin percentage. Because we're only given in euros, we're not given in units, we can't say it's 50 times the contribution per unit, because we don't know the number of units. So one way of going about it is the CM, the contribution margin ratio, is your CPU divided by your sales price. So what essentially that is, it's what percentage of every euro in sales goes towards contribution. So it's like a margin, like your gross profit margin, except now we use contribution. And in our case, it's 18 over 30. 18 of every unit sold out of a selling price of 30 goes to contribution. So 18 over 30 there, your contribution margin is 60%. So if we know that, we can say the impact on profit will be 50,000 times 0.6. Because remember, fixed costs won't change, so whatever you increase your contribution by, you'll increase your profit by, because fixed costs are a flat figure each period. So therefore, if we increase our sales by 50,000, 60% of that will fall to contribution, so that means an extra 30,000 in profit as well. Because remember, your fixed costs don't change, they don't go up, so whatever increase you have in contribution will be the increase in profit. And it's no harm to prove that as well. So use your approach to prove it. Look at your P&L. Start with your sales revenue, etc. So go down and have a proof of that. Our sales, we're told, are gone up by 50,000, so they're 450 plus 50. Now, our problem is here, we don't know what our variable cost should be, but we can prove it that if our contribution is 60%, our variable cost must be 40%, because the sales are 100%. So 100% is sales. Your contribution margin, which means what percentage of sales falls to contribution, is 60. Therefore, your variable costs must be 40, which is 200. That means your contribution is now 300. Your fixed costs do not change. And now we see our profit has gone to 84. And you compare that 84 to the previous 54, and that means it's gone up by the 30. So we can prove we're right. Now that was a very tricky one. It's testing your knowledge of using the contribution margin ratio, but that was only one method. There is an alternative method I'll show you as well. So the alternative way is using the contribution per unit, which we're used to, using your CPU. So because we're given it in sales revenue, we first need to figure out what extra units does that mean. So we're saying if we sold 50,000 extra sales, you get your 50 divided by 30, because each unit we're assuming is sold for €30 a unit. That means additional sales of 1666.66. Now you can round if you want, it won't be exact, but we won't round because we're working in Excel. So the extra units sold were 1666, and the contribution per unit is 18. So if we sell an extra 1600 units at €18 a unit, gets us extra profit of 30. So either way would have got you to the same answer there. It's just a matter of which one you would have seen. Both would have gained full credit. That if you increase your revenue by 50, that means 30,000 will fall to contribution, and it'll still fall to profit as well, because your fixed costs don't change, so it falls directly to the bottom line. And lastly then, note 5 is your margin of safety. So your margin of safety in units is your sales minus your break-even sales. So you're essentially saying, right, how far away am I from my break-even point? Now in this question, it's going to be your current sales level is 15 and your break-even level is 12. So what that means is your margin of safety here is 3,000 units. So if you're asked to present it in units, that's what you'd say. Sales could fall by 3,000 before you would break even. However, we can also present margin of safety in percentage. And we're saying what percentage of a turnover or unit decrease can we have before we break even? And you put the 3,000, which is the difference between these, divided by your sales, which are 15. What essentially we're trying to see in relative terms, well, you can say 3,000, but that doesn't really give you, well, is that a big or small amount of our current budgeted sales? You're told the company made and sold 15, so 3 over 15 is 20%. So your margin of safety expressed there can be expressed as 20%. What that means is, if you're asking a question, sales can fall by 20% before the company starts to make a loss. So you have a nice margin of safety there in case anything goes wrong. The selling price might fall, costs might go up, or the volume might fall. So if the volume falls by more than a fifth, then you're going to start making a loss. Right, so that was the a starter question on CVP analysis. You now need to go back, have a look at the slides, and then graduate on to the Gallagher question, Concert Co, and Peter Allen.